So we're continuing on Descartes' rule of signs. This time we're focusing only on the imaginary solutions. But in order to get the imaginary solutions, we first have to find all the positive and negative possible solutions that are out there. Okay, so if you remember, for our positive solutions, I just look at the signs of each of my terms. Blue. So x to the 6th is positive, negative x to the 5th, negative x to the 4th, positive 5x to the 3rd, positive, negative, negative. Okay. And then we look how many times does the sign change as we go through. So I see one change here, then negative back to positive, and then positive back to negative. Looks like we've got like 3 kind of winky faces here. So we have 3 potential positive solutions. So if I was going to start my table, right, so positive solutions, we have either 3, or remember if there's 3, we also have to count down by 2s until we either hit 1 or 0. So if there are 3 positive solutions, there's also potentially just 1 positive solution. Okay? And then for our negative answers, I want to know what happens if I take f of negative x equals, and hopefully, as you do more of these, you don't actually have to write all of this part down. You can just kind of see what happens to the x values, and their signs at different exponents, because you know all the positive exponents and all the negative exponents follow the same kind of rules. But if you need to write it down, that's not bad. It's just going to take a little bit more work. All right, so I'm just rewriting my function using negative x instead and hoping I don't run out of room. I'm going to start squeezing here. Minus 6 times negative x minus 36. Perfect. Okay, so then I look at the signs here if I simplify this. So negative x to the 6th power, that's going to be positive. Negative x to the 5th power is negative, but then it times a negative coefficient will become positive. Let's see. Negative x to the 4th is going to be positive times a negative coefficient, so this is going to end up being negative. Let's see. Negative x to the 3rd is negative. It's positive, so it's going to stay negative here. Negative x squared is positive times a positive coefficient is positive. Negative 6 times negative x, that's positive. And then minus 36 is just a minus. So then I look at all the times that our sign changes here. So I see positive to negative, negative to positive, and then at the very end, positive back to negative. We got another 3 winky faces. So our negatives, we have 2 options there. It can either be 3 or 1. Right? Same idea. If we have 3, we also have to include 1. And then we need to write out all the possible outcomes we can have. So we can have 3 and 3, we can have 1 and 1, but we also need to know what if we have 3 positive and 1 negative, or 1 positive and 3 negative. So there's 4 different possible ways that we could set this up, right? Okay, and then the last part, which I wasn't super clear on, I guess, as a lot of people are asking me, the total number of solutions, which was our, write in imaginary and then total. So people are asking, how did we get the total number of solutions? And that is always based on the highest degree. So if this is x to the 6th power, it means there are 6 solutions out there somewhere, and they have to either be positive, negative, or imaginary. So for all 4 of my situations here, the total of these 3 first columns needs to add up to 6. Okay? So if I have 3 positive and 3 negative, then I have 0 imaginary. 3 plus 3 plus 0 is 6. If I have 1 and 1, that leaves 4 to be imaginary. 3 and 1, so 3 plus 1 plus 2 is 6. And 1 plus 3 plus 2 is also equal to 6. So how many possible imaginary solutions are there? It's either 4, let's put comma, 4, or 2, or 0 imaginary solutions. Okay. But be careful of these ones. A lot of the times it will work out the same way as positive and negative, where you have the highest number and then you count backwards by 2 until you get to 1 or 0. But that is not always necessarily the case. Okay? It is a lot of the time, not always. Especially if you skip over exponents. Like this one goes 6, 5, 4, 3, 2, 1, 0. Right? And so we get a nice clean answer here. But if we took out some of these middle terms, we wouldn't necessarily end up with 4, 2, and 0. Okay, it could change everything. So just be careful if they skip over some powers in the middle. But that's it. So make the tables. Find your positive and negative combinations, and then recognize the total number of solutions is based off of the highest degree in your original function. And then know that the first 3 columns, when you add them up, always has to add up to that total on the right. Okay? Hopefully that makes some sense. So try these out. Just 8 problems today, and then you take a picture of your work and you send it to me, and hopefully you'll get 100. All right. Good luck. Have fun.